Hello everyone. First of all, I would like to thank this wonderful Galp and Hackathon community organizers for organizing this event. As mentioned in this challenge, Galp's 1500 plus locations in Portugal and Spain serve hundreds of thousands of community members, and I feel very proud today to shape the future of retail in this project. I'm hoping this project may bring some positive changes to operating this kind of high-performing business operations. My name is Amit Shukla, and you can find me at GitHub at Amit X Shukla. In this video today, I'm here to present my project eCommerce.ai, which addresses challenge number 2, optimizing in-store product assortments and estimate potential sales volume. I want to mention as exciting this challenge is, like was equally difficult was working on this solution, which I'm here to propose today. I want to take a minute here and discuss how my project is structured in this GitHub repository. The first stop is the readme.md file. And as you can see, there are two branches, GH pages and the main branch. GH pages is the branch where you will find all the source code executed as published as a static HTML website. Let's take an example. I'm reading a data.md file here. This is the markdown file. And if I go through the GH pages version of it, let me browse through it. Here you will see the executed version of the code. This is the reason I prefer if you go through the solution through GH pages branch. I'm using Julia language, FluxML AI framework, and Oracle Graph Foundry as my technological tools. However, this same project can be implemented in Python, PyTorch, or any other graph databases. Only reason I'm using Julia language because commerce data or most of the ERP data is often very huge in size. And Julia works better if you're working with the petabytes of the data because it has inbuilt support for distributed parallel computing over GPUs. I suggest start reading through implementation approach first. Step number 1, as you can see, more time is spent on the detailed analysis. That means understanding how business works. Second thing is we have to collect some other market data, that is IoT data. Third step is we combine all of this data through an ELT platform, and then finally a set of reports, that means ad hoc reports, analytics, advanced analytics, predictive and real-time analytics reports are delivered. I also included a high-level proposed architecture diagram. Let me make it a little bit bigger. All right, so here as you can see, the ERP information, that means the data related to the commerce, is key to this whole project. I have included a tons of real life examples. So for example, sales revenue register, order registers, and you'll be able to find entire data set inside this repository. As you can see, let me browse through a couple of the examples here. Sales and revenue registers. Here the sample size are 1000, but personally I have tested the solutions on gigabytes of the data. And I have included all the scripts so that you can execute it yourself. As you can see, I have included a couple of the financial data for the Galp Retail INC. This data looks very real and actually resemble to the real life data, and this is totally based on my experience. However, it's not actually real. This is the data, the dummy data I have created. As you can see, I have also created a lot of different dimensions, say vendors, procurement, and organizations, locations, etc. All right. Organizations. So I'm creating a fake organization hierarchy. In real life, as I mentioned, Galp may have more than 1500 or 2000 locations. So in real life, you can just take those locations, try to fit that data into this location master here. Let's go back to implementation strategy. As you can see, I have also created a workflow diagram. This is very important piece of this project. Here, I have tried to understand how customer interact with the sales register, revenue registers. He may choose to buy some goods from any of the retail store. At the same time, he may return something. I am assuming we have some software to capture all these transactions. Let's take a minute to understand how the entire procurement to pay operation works. So most of the time, any retail INC, it always starts with the MSR, that is material service request. People or your buyer in your organization, they create the requisitions, and requisition becomes a purchase order. Purchase order sent to the vendor, and then vendor finally, once they see a purchase order, they send you the goods and you do the receiving. So as soon as you receive something, you accrue in liability. This is the typical ERP process. We don't need to go into too much detail into that one. But the point is, all of these transactions impact how the customer interact with your products. So knowing all those ERP business process definitely helps you predict your sales in advance. As you can see, I have also created a physical ERT diagram to mimic this business operations. You'll find tons and tons of examples here. Again, this looks like very Oracle or SAP kind of a ERD structure, but it can fit into any of that. It's very flexible AI structure I have created. Next step is the Internet of Things. This is very, very important piece of information. You need to know in your community what's going on. So for example, you need to be aware of the events, the holiday calendar. Like if there is any, people tend to travel more during the weekends. Everybody knows that. Or any holidays out there. Is there any events? Also, the weather data is very, very important. Definitely some goods sell at, they are more in demand during daytime and in hot weather. Also, there are a lot of other IoT data I have included, sound activities, which may not be that applicable here, but I have just included for the future. So for example, if there are too many people all of a sudden appear in your area, okay, that definitely is not like news. If there is any breaking news in your area, something you need to be aware of which can impact your sales operations. So these are all the IoT data. I've already created a lot of examples here which you can use in your analysis. Last piece of this implementation approach I want to call out is the explainable AI. So here all I did, and you will be able to find all of this source code, executed source code inside the Jupyter notebook inside my GitHub repository. I'm taking all of those IoT's data, sales data, order history data. Again, I didn't get a chance to create AIs for everything, but the point is I am using ELTs to gather all the data and then training my machine learning model. First, I need to extract, clean, and wrangle the data. And I actually, in fact, I used two of the Oracle 8 OCPU machines to train a couple of machine learning time series SARIMA model. That means seasonal auto regression, integrated moving average. And then I was able to predict these reports, what I'm going to show you in a minute. So let's go to the demo section, and here you will find all of these reports. So as you can see, there are different type of reports. So for example, ad hoc reports, not everything needs machine learning. Only the predictive part, here you need the machine learning where you need to train your machine learning model based on the existing data. But otherwise, so for example, I have included a couple of examples like guided buying. So for example, during hot weather, what item sells more? Or is there any, how many items you have on hand of the quantity? You will find like all of the different executed examples. Let me show you one advanced analytics Jupyter notebook here. So let me, at this time the GitHub is not able to execute my code. I will fix that later, but let me show you the VS Code version here. So here you can see all of the executed code here. You will find how I have created the data and how I have used the data and tried to create some analytics on top of that. I learned some, like, I'm using Jupyter Notebook widgets to create, like, prompt the data. Okay, show me all the supply chain, show me all the items, sales by vendor, by accounting period, things like that. And the same thing, like, I have used some advanced analytics like would have, could have, should have. So for example, if I would have invested this much item in this item, this much money on these items, or like, if I increase the price on this particular item, how much is the impact? Again, you will find different type of examples. I didn't execute it for everything, but I'm trying to include one notebook per type of examples. There's a lot to cover and there's a lot of detail inside. Unfortunately, I won't be able to cover everything in this video today. But if you have any questions, please feel free to fork this repository, open an issue log, and let me know. I'll be happy to help you out. But last, I want to thank all the community members and Hackathon organization community members for organizing this event. This was the very, very challenging project, and I am proud to say that I really, really enjoyed working on this project. No matter what the results are, I will be taking this project forward because this is, I'm proud of what I've created. Once again, thank you very much for watching, and please connect with me on Twitter, GitHub, and YouTube. Thank you.